Okay, welcome back to the Azure AZ Fundamental 900 tutorial. Again, my name is Everett Morris from NetMerge, and we're going on part 2 or section 2 of 6 of the Azure Core Services and Architectural Component. So what I'll be covering in this section, will strive to describe architectural components. We'll be looking at region and region pairs. We'll be looking at availability zones, which are data center. We'll be talking about resource groups. We're talking about subscription, management group, Azure Resource Manager, and as Azure Resources. We'll get our hands and feet wet a little bit with the Azure Portal. Then we'll go on to the second session where we'll describe core resources available in Azure. At that point, I'll go over the session outline and the course outline for that session. So let's begin by looking at the core architectural components in Azure within this particular section. So first, at the high level of Azure, I want to go over the structure so you have a better understanding of what we're going to be talking about. The course outline wants to talk about region and region pairs first and foremost. I want to actually explain to you the overall hierarchy before we get into regions so it's easier for you to understand and you won't be overwhelmed at all. So at the highest level in the Azure core infrastructure, we have the zone, which is at the top of the hierarchy, and it's used for transfer and data transfer and billing purposes. And there are approximately 5 zones in Azure. We'll talk about them next. Below the Azure zone is what we have is a Azure Geography. It's the second highest on the hierarchy scale, and it is used for residency, sovereignty, demarcation zone, and compliance demarcation within a particular geography or a particular geographic region. Next, we have below the geography is the Azure region, and it is the first physical point or actual physical point of contact in the resilience structure. So it is actually a part of the core infrastructure that we'll be talking about. A region is a combination of 3 or more availability zone or data centers. So availability zone is actually a data center. And at the bottom of the chart, we have availability zones, or they're referred to as AZs, and it's a data center and it's a fundamental structure of the Azure region that we'll be talking about. So you get a good understanding as to what the entire or the overall structure looks like. We talk about the zone, we talk about the geography, we talk about the region, and we talk about the availability zone. What I'm going to do now, I'm going to look at it from the bottom up so you get an understanding of how the overall infrastructure is constructed. So at the bottom of the infrastructure is the Azure availability zone. And an availability zone, as we come to know it, is a data center, a physical secure, where you have your own physical security, your own technical security, your own building, your own servers, your own staff, your unique network, your electricity, your cooling system, and all that. So an availability zone is simply a data center in Azure. Now, each server or virtual machine in an availability zone belongs to what is referred to as an availability set. As I explain availability set, you'll get an understanding of how high availability and updates are done to make services current in Azure. We talk about services being current, but we're going to explain how that is done and how transparency is maintained when that is being done. So an availability set is the magic behind that happening in Azure, and we're going to look at it. So an availability set, which is a combination of both a fault and an update domain, is used in Azure, and each virtual machine must belong to an availability set. So these are logical grouping used to promote resilience in both planned and unplanned situation. So a planned situation would be a situation where you're doing an update, that's a planned event. And unplanned would be like an hardware failure or a natural disaster. So you get a core understanding of what constitute an availability zone or what it is made up of. So there are rules around these three logical grouping in a data center. There are rules about what a fault domain entails and also what an update domain entails. Now let's take a look at the Azure region. An Azure region, which is above the availability zone, this is a solution that Azure presents as an area of service to the public. And I'll talk about that area of service again further down. Now, an Azure region is made up of approximately three availability zones. And an availability zone, again, remember, is a data center. Now, each availability zone or data center is strategically placed. They're not just placed wherever there's land available or there are buildings available that Microsoft could use. There's rigorous and stringent assessment processes that are undertaken for risk assessment. So these are strategically placed, and each availability zone within the region are connected to each other for data redundancy. So this is AZ1, AZ2, AZ3. If one goes down, 2 and 3 is a backup. If 2 goes down, 3 and 1 is a backup. If 3 goes down, 1 and 2 is a backup. So this is what an availability zone would look like, and this is what an overall region would look like as well. Now, these three folders I want to use to explain LRS, which I'll expand on a bit further down. This is your Excel data that I spoke about. So if you create an Excel file, you'll get 3 copies of that file resident in a particular region in a particular AZ. So within one of the 3 AZs, you'll have 3 copies on disk for this particular file, and that is part of the redundancy strategy in Azure, and you get that by default. I mentioned it briefly before. I mentioned it with a lot more detail now, so you're getting a better understanding of how your information or how your data is stored inside of Azure. Now, an Azure region is deployed within a low latency defined perimeter of approximately 300 miles apart. So approximately every 300 miles or 483 kilometers apart, you'll have a new Azure region in a particular geography or within a particular country. Not every country would have more than one region, so not every country has the liberty of having 2 regions within their geography or within their country or within their boundaries. Just want to make that clear. Now let's take a look at Azure. It has approximately 60 regions. I talk about that across 140 countries with 22 geographies and 5 billing zones. We'll talk about the billing zones. We're talking about the regions. We're going to be talking about geographies next, and then we'll talk about the Azure zones, and you'll get a better understanding of the billing zones as they exist inside of Azure. So at this point, you should understand what an availability zone is, and you understand what constitute an availability zone or a data center. You understand the physical security and the components that make it up. You also understand what a region is. It's a combination of 3 availability zones, and you understand how they're connected and how the data is stored within that particular region. Now let's move on and take a look at your Azure geography. Okay, before we do that, let's talk. I mentioned LRS, and these folders that I mentioned are stored in LRS. It's local, it's referred to as local redundancy storage. And LRS is done on a single AZ. That's the most important thing to remember at this point, apart from remembering the acronym. So LRS is saving 3 copies of a particular file in one availability zone. So that is LRS for you. Now, there are also, when we talk about regions, there are also special regions, and you'll learn more about them in Azure when we talk about government regions in China and the United States. And these are mostly government regions designed to meet extra special compliance standards and legal requirements. So you'll have government requirements that will necessitate the need for special regions in Azure. So I want you to understand that as well. In the US, we have such region. It's called the U.S. government. So we have U.S. DoD Central, we have U.S. government Virginia, and we have U.S. government Iowa. So those are three special regions within the United States that is created specifically for government. Now in China, we have two regions, China East and China North. These are not part of the typical region that we're going to be having access to in Azure. I'll explain that some more. So China East and China North are two regions that are available through a unique partnership with Microsoft and a company in China referred to as 21 ViaNet, whereby Microsoft doesn't directly maintain the data centers in China. They are operated by 21 ViaNet using a special license and agreement with Microsoft. We'll elaborate on that as well further on, but I just want you to give you an understanding that there are special regions referred to as government regions in Azure. Now, Azure service regions are divided into two main categories. They are what we refer to as recommended regions, and that's the regions that we'll be operating with. So even though Azure has 60 regions, it's only 23 of those regions are recommended regions. The other regions are referred to as alternate regions or other regions in Azure, and you'll see those regions as we go along. Now, the recommended region have the broadest set of service capabilities in Azure, and they support availability zones now or in the future. Now, an alternate or other region operates with data residency region with boundaries. These regions are labeled as other in Azure, and they do not support availability zone. So the availability zone that we spoke about and the different having three availability zone in an Azure region, those are for recommended region. So of the 60 region that Microsoft has have worldwide, only 23 of those are recommended regions that you have access to. Now we want to talk about general availability. I'll talk about it briefly here and we'll talk about it again. General availability is when a service is considered ready to be used publicly by everyone. It's available to the general public. Azure Cloud Services are grouped into three categories that determines when a service is available. Now, the first category is referred to as foundational. It is when a service is generally available now or within 90 days in both recommended and other regions. So again, the service is going to be ready within 90 days in the recommended region and also in the other regions. There's also another service called Mainstream, and it is in all recommended region within 90 days of a region's general availability, and they are on demand in the alternate region. So the only difference between the foundational and the mainstream region is that the services in the alternate regions are offered on demand. You have to demand or request those services. They're not available to you by default. Now, the third service is referred to as strategic service, and they're targeted using specialized hardware, and they're demand driven. So both in the recommended and the alternate region, they're all demand driven in the strategic region, and they use different hardwares in those particular region. So I hope you understand general availability and the three types of categories that are under general availability. Now let's move on and talk about regions. This is a list of the regions that are available with availability zone. And again, I want to point out that there are 23. Now, if you look at the different regions, you realize that China is not on this list. So you have the Americas, Europe, Africa, and Asia Pacific. You could view them in detail at your leisure, but this is a generic list of the regions that has availability zones. Now let's take a look at the Azure Geography, which is on top of the region. Now, a geography is a discrete market with one or more regions, and it operates with data residency and compliance boundaries. Each Azure Geography meets specific residency and compliance requirements. So this is like a demarcation zone. So let's say, for example, you are running Facebook in Europe or in the UK, and the laws prevent you from storing the user information in another country. You have to, that the information must be domiciled within the United Kingdom. That is an example of a geography. So that is the reason behind geographies in Azure. They're not really a part of the core physical infrastructure. They are created so you have zones of operation that you could use within Azure. So that's the purpose for the geography. Now, some Azure geography includes Canada, the United States, Mexico, Brazil, and Azure government, and that is the one we spoke about in the United States before. Again, it might be a requirement for law, data law, that the data is domiciled within a particular country. This is an example of a Azure region and a data center. So this is actually a particular geography that operates within Azure. It's an example of a geography, I should say. Now let's look at the Azure Zone, which is at the top of the pyramid. I spoke about it briefly and I promised I would come back to it. So Azure has these geographic grouping of regions, and this is done for billing purposes. Again, there are different transfer rate for data in different parts of the world. So the zones are not a part of the physical infrastructure. They are done as logical grouping for billing purposes. So let's take a look at the different billing zones that are in Azure. So this is zone 1. It covers Australia Central, West US East, US Canada West, West Europe, France Central, and other. Again, other is a type of alternate zone that I spoke about before. Now, if you take a look at zone 2, zone 2 covers Australia East, Japan West, Central India, Korea South, and other. So they all support other. Now the third zone is Brazil South, South Africa North, South Africa West, the United Arab Emirates Central, and EAU North. And then the final zone, DE Zone 1, is for Germany. It covers Germany Central and Germany Northeast. So there you go. You get a good understanding of what the different zones are, and I look at the overall structure. Now I'm going to go back to where Microsoft wanted us to start initially. We're going to take a look at what is referred to as region replication or cross-region pair. So what we're going to be doing, we're going to be taking a region, and a region is comprised of 3 availability zones, and we're going to pair 2 regions together for additional redundancy, and it's called region pairing or cross-region replication. So now that you understand availability zone and you understand regions, it should be easier for you to grasp the actual setup and construction of a region. Now, what's the purpose behind the cross-region replication? It is to maintain business continuity in any situation. In a natural disaster, a wide-scale natural disaster, if a disaster should wipe out an entire geography or an entire region, another region 300 miles apart should be a backup for that particular region. So business continuity is the main reason behind pairing and replication. Disaster recovery is also another reason for that pairing as well. So at the core, it's part of Azure's resilience strategy to use cross-region pairing to help create a resilient infrastructure that could withstand wide scale and broad disasters. So that's the reason behind the replication. So here's a diagram of the cross-region replication, and you could see the 2 pairs being joined in one geography and 2 more pairs joined in another geography. So you have a general understanding of what region pairing is. Now let's take a look at the business continuity and recovery storage and how information is stored on a system or a server within an availability zone. So I spoke about LRS and I said all you need to do at the time was to remember the acronym local redundant storage, and you get 3 copies of your Excel file within that availability zone or data center. Now, according to Microsoft, they're providing you with a service level agreement of 99.99 dot with 99% uptime, which is referred to as 11 nines. So there's a total of 11.9 SLA percentage that you would get with an LRS. So that is 3 copies in a single availability zone. Now, ZRS is referred to as zonal redundancy. I'm not sure why they didn't call it regional redundancy, because what it really means is that in a particular region, ZRS gives you 3 copies of that same file, but they're not on a single availability zone. They're on all 3 availability zones within the region. So they call that zonal redundancy, and it's called ZRS. So you understand LRS, and I covered ZRS. Now let's take a look at GRS and geo redundancy. I spoke about this before as well. Now I'm going to talk about it in detail briefly. Now, geo redundancy storage give you synchronous storage using LRS in one AZ. So synchronous storage means real-time storage. You're getting it LRS, meaning 3 copies in one AZ in the primary region. Now we're talking about region replication. Stay with me. Now in the secondary region, you get asynchronous backup, which is delayed backup on a single AZ in the secondary region. So GRS is giving you 3 copies in the primary region real time, and in the secondary region at a delayed pace, but you're getting 3 copies in one AZ in each region. Now there is GZRS, which is Geo Zone Redundancy Storage. It gives you synchronous storage using ZRS, meaning you're getting 3 copies in all 3 availability zones in your primary region, and asynchronously in your secondary region, you're getting delayed storage on one AZ in that particular region. So if you want to look at it in context, GRS and ZRX, they're both giving you secondary storage in your secondary region on one AZ. But what they're giving you in the primary AZ is different. You're getting 1 AZ for GRS and 3 AZs for GZRS. And that is the different types of storage that you're going to be getting when you use these different models. It's a lot, but you'll get it after going over the concept more than once. But this is how it works for storage. All right, let's move on from storage so you understand storage, SLA a little bit, and now we're going to be looking at the concept in a visual manner. Now here's a primary diagram with ZRS, and it's showing you that you're getting zonal storage, and zonal again mean the entire region. So if you look at your Excel file, you're getting 1 copy in each availability zone. So you get 1 in 1, 1 in 2, 1 in 2, and 1 in 3. That's your 3 copy. That's your primary zone. This is your secondary zone. That's your 3 copies on one AZ, and that is the ZRS on the left, and it changed to GZRS on the right. And that is an illustration of what I just explained. So you should be able to understand it now looking at the concept visually. Okay, now what we're looking at as well, we're looking at GRS, which is a geo redundancy storage, and here are your 3 folders. So you're getting 3 copies on your first availability zone, and you're also getting 3 copies in one AZ in your secondary region. So you're saving 3 copies in the first region and 3 copies in the secondary region. That is what GRS is. I hope this helps simplifies it a little, and I hope you're able to understand it a lot better with the illustrations as well. Now, let's look at the core benefits of region pair. Now, the number one benefit is you're getting synchronous storage in your primary region and asynchronous storage in your secondary region That's one of the benefits of region pairs. Now, the next benefit you're getting from region replication is high availability with exceptionally high redundancy, durability, and extremely high availability for business continuity. So remember, business continuity is one of the primary benefits you're getting. Next, you're getting recovery sequence. Priority recovery sequence structure guarantees priority in a recovery sequence. Now, if that's confusing again, let me try to explain it. If you are pairing two regions together, let's say, for example, region A and region B, if Microsoft should have a wide-scale natural disaster that wipes out a geography or an entire area, they're going to try to bring back one pair from each sequence online at a time. So if A and B is paired together and C and D is paired together, they're going to bring up A and then C and in that order. So if you have both, you're going to guarantee that at least one pair in your sequence is going to come up before the other. If you don't have a pair and unfortunately you're in B region and A should come online, there might be a significant delay before B is restored, and then you would have downtime. So that is one of the benefits. It's referred to as recovery sequence, priority sequence. So you get an understanding of what that is. A next benefit is sequential updating. Region pairing updates are done sequentially and chronologically. I'm not going to confuse it with this one at the moment because we're going to talk about sequential updating and chronological pairing when we talk about domain updates further down and fault domains. So at least you just need to remember that there's sequential updating that you will get from region pairing as a benefit. Next benefit is physical isolation. So the fact that the availability zones the fact that the availability zones that within a particular region are isolated because each region are approximately 300 miles apart. There's this buffer zone. If you have a natural disaster 300 miles away, it's unlikely that you'll have the same natural disaster impacting you 300 miles away. So you get physical isolation with region pairing. Now, the next thing you get with region pairing is what we call composite SLA. You get up to 16 nines for mission critical application that you use when you combine two regions. So you have an SLA for the first region and an SLA for the second region. When you combine them, you get what is known as a composite SLA with greater availability and better uptime. So that's what composite SLA is, and it is also one of the benefits that you get. All right, so that covers the benefit. Now let's look at it in totality. We're seeing the different regions. We're looking at the pairs again. So this is a region right here. We're seeing region pair at work, region pair at work. Now, one thing I want you to understand is that, again, your data is automatically paired to 3 AZs in the same region when you create a resource service using the zonal storage. It's not the LRS, it's a zonal storage. So you get 3 AZs that are paired in that region. You get LRS right there. Now, when you do region pairing, it's not by default. You get zonal service, you get 3 copies by default on a particular AZ. Region pairing are not by default except for geo-redundant services. And I explained to you what geo-redundancy is in region pairing. So you have to pair these on your own, and it comes at an additional cost. So you would have to do a cost-benefit analysis to see if you want to do redundancy using region pairs. But when you do that, you could also isolate your critical solution and only do replication on your critical solution. Additionally, you cannot literally create your own region pairs, and you'll understand that when we look at the region pairs. If you create your own region pairs on your own, Microsoft wouldn't be able to differentiate in when they're doing the paired sequencing and the restoration. So you have to use the region pairs that Microsoft designate. You can't pair your own region together. So we'll need to understand that it would cause ambiguity, it would cause chaos, and it would be a royal mess. So you're not able to do your own region pairing in Azure at all. All right, so this is an example of a region pair and what a region pair looks like. Now, when we talk about region pair, I jump right to China. You could see where China North is paired with China East, and China North 2 is paired with China East 2. So they are able to do their own pairing in China. But again, it has nothing to do with Microsoft Azure. It is done through a partnership agreement with 21 via net. Now, I want to move over and look at Brazil. If you look at Brazil, you realize that Brazil South is paired with South Central US. This is because Brazil only have one region within that country. So they're using the United States as their backup pair. The difference is this is not bidirectional. Brazil is backing up in the United States, but the United States is not backing up with Brazil. It's the same situation with Singapore, and those are the only two countries in the entire ecosystem that doesn't have their own backup within their own country. So I want to give you an idea and I wanted to point that out for you. Now let's move on. Let's see what else we got here. This is the second pairing chart. If you look at the top, you realize it's saying 25. But remember, the two regions in China are not a part of it, so it's really 23. But you still get an understanding of what the pairing look like and how the regions are paired in the different geographies by Microsoft. So they give you, you're not able to do your own pairing, but at least they give you an understanding of how the pairing is done and how the pairing actually works. Now let's take a look at availability zone in depth. What I'm going to be doing, I'm going to be talking about fault domains, and I'm also going to be talking about update domain, and then the concept of how sequential and chronological updating is done and why it is seamless to you should become a lot clearer once I explain to you how the availability zones do the peering and the updates. All right, so just take a minute and we'll come right back to that peering. All right, so let's take a quick look at the availability zone in depth. Now, you have to understand region peering and what the key component benefits are. Let us go back at the availability set and let us talk about fault domain and update domain and availability set. I touched on it briefly and I promise you I will come back to it in detail. So a fault domain is a logical grouping or a subsystems of virtual machine that share the same network hardware. So you're sharing rack, switch, power, cooling system. It has a single point of failure, same network. It's using the same switch. It has one point. So if the network fail, if the switch fail, if the power supply fail, the entire rack fail. So consider the fault domain, visualize it as a rack filled with server. It's vertically and it's standing vertically. You could only have 3 fault domains in an availability set. So that's what you need to remember about fault domain. Now let's look at the update domain. It's the same logical grouping as your fault domain. That stretches, but it stretches across fault domain. So it's not going vertically like your fault domain. It's going across all your fault domains. So if you have 3 fault domains, your update domain will stretch across all 3 in an availability set. You could have up to 20 update domains in an availability set. So you could have 3 fault domains vertically or as a column, and you could have 20 update domain going across horizontally as a row. Now let's put it together as one fault domain and look at it. An availability set is now a combination of 2 or more virtual machine with both a fault domain and an availabilities and an update domain abound for each availability set. And again, the availability set can only have 3 columns or 3 fault domain and 20 rows, or it could have more than 20 rows, but it cannot have more than 20 update domains. Now to drive this point home, let's look at this illustration. There you have 3 different fault domain or 3 racks of servers: domain 0, domain 1, and domain 2. Each of them have 5 virtual machine inside of it. The first virtual machine is also your update domain. So when you run this update, it will go across your fault domains and you will have machine number 1 and machine number 6 and machine number 11 will be updated first. Now 30 minutes later, it will, after it was updated, it will reboot, and then the second fault domain will take effect. So the second fault domain is on virtual machine number 7, and it will update virtual machine number 2, then number 7, then number 12, and it will continue in this order within 30 minutes interval until the entire stack is updated. Now let's, for example, say for example you're updating the first one, and all these servers in the first update domain should go down. In each rack, you would have 4 remaining servers that would keep you up and running optimally, and no downtime would be realized on your network. So, and that would be the same for any of the update domains. So now you understand why an update domain is transparent and why it's done sequentially, one after the other, and why it is done chronologically as well, because it's done in 30-minute increments. So this should help you understand what an availability set is. There's one more point I want to mention. If you should have a 6 machine in one of these racks, say rack number 0, that machine would default to update domain number 1, and that will take care of 6. Or you could, even if you had 5 more machines, all 5 would default back. Number 1 would default to this one, number 2 would default to this one, number 3 would default to this one, number 4 would default to this one, and number 5 would default to this one if you add 5 additional machines. All right, so you get a good understanding of how the fault domain and the update domain work and what an availability set is. Now let's look at the benefit of the availability set now that we understand what it is. High availability with tolerance for failure is achieved in redundancy and logical isolation of Azure services and resources. So you get high availability because there's logical isolation. Now you could understand what sequential update is, how it is done, and why it is done in chronological order. That's why I said to, just think about that one, but don't try to understand it too much at that point, because now you have a better understanding of what sequential update is and what the chronological order is. So that is a benefit of having the availability set. Now, fault tolerance. If one entire rack goes down, you still would have 2 more vertical racks of servers. If an entire row goes down, you still would have 4 more rows of servers available. So either way, if you have a fault or an update issue, you still would have redundancy based on the logical vertical and horizontal ordering that they're grouped in. Now, high performance, you get high performance because of the close proximity and the high fiber networks that is used to tie the servers together. So there's low latency between the AZs, so you get good performance from that low latency. You also get zonal redundancy in some situation, and you get hybrid redundancy at the regional level if you're doing region pairing as well. So the availability set also helps with those things as well. Now, let's take a look at the Azure Portal. We are going to go into the Azure Portal, get enough look at as to what it is, and get a feel as to what the portal is. The Azure Portal is your dashboard and unified command center. It's a graphical, intuitive user interface that you would use to work inside of Azure. It's like your virtual office space. It's where you would do all your technical work, and it's done through the browser. So what I'm going to do, I'm going to go over into Azure so you could take a look at the portal. You can use the Azure Portal to create new resources, to manage existing resources, to delete resources, deprecate resources in your account. So it's like your command center, it's your command central, and we're going to take a look at that. So let's go over and take a look at your Azure Portal. Now, understand, we've talked about subscription, and I mentioned that you must have a subscription in order to work in Azure. The thing is, you cannot have 2 subscription or 2 main account in Azure, and I already have a subscription, so I won't be going through the detailed process of creating an account. I'll try to see how far I could guide you before I switch over into my personal account that I have set up for the training course, but I already have an account created for my training. So you might not get all the benefits of going through it step by step, but it's very user friendly and very easy to use. So let's type in Azure and see what comes up with the Azure portal. So we're going to be looking at Azure. Let's go to the Azure portal so we get an understanding. Again, you want to make sure it's a Microsoft portal you're going to. You click on it. It says new to Azure. If you're new to Azure, it says if you want to start free. At this point, it will give you a free account. If you're in the United States, you get approximately $200 worth of free credit that you could use to play with Azure. You would need a credit card to help verify you in Azure. At this point, I can't go any further because, as you see, my account is coming up. So I'm going to log into Azure just to give you an understanding what the landing page is like. Look, you already have an account. Again, once you're verified and you have an account, you can create a second account with Azure. Now, I'm going to use the pay-as-you-go subscription that I have. And this is what Azure looks like. I want you to get a good feel or understanding of what Azure looks like. These are some of the resources I have in Azure. This is the actual dashboard. Let's go back to the home screen. So this is just a general overview or a general understanding of what the Azure platform looks like. So I will be coming back to it from time to time to give you a little hands-on experience with different pieces of Azure, but at least you get an understanding of what the general Azure platform looks like. So I'm going to move on from there and we're going to continue looking at different services within Azure. Now, okay, resource group. You should remember this term. We spoke about it at the very beginning when we talk about terminologies. So a resource group is a single logical collection. Again, it's another logical collection of related Azure resources that stores metadata about each resources you wish to manage as a group. So you could use a resource group. I gave you the definition, but I'm going to actually explain to you what the purpose of the resource group is. Let's say, for example, you're managing a project for a client and you want to keep track of the resources that you're using so you could build a client for it accurately. You might want to create a resource group to store your user information, your virtual machine, and all the resources that you're going to be using for that project. So that's a good reason why you would want to have a resource group. Resource group provide a more granular management of resource than you would have at the management subscription level. So you get a more granular or a more detailed form of management at this level. Now it can get even more granular if for each resource within the resource group you actually manage them at that level, but the resource group allows you to group things together and manage it at that higher level. Now here's an example of a resource group. You have your network, your virtual machine, your internet, and your database server. So a resource group is a great way to organize resources. For many reasons. Whatever the reason is that you have, you could organize your resources in a particular group. This is more ideal and better understood in a very large organization. If you have a really small company, you might not see the true benefit of having resource group. But if you have a large corporation with thousands of employees and you're running a lot of projects, a lot of departments, a lot of groups, then you'll understand how beneficial the resource group is. Now let's take a look at the resource group benefits. Talk about beneficial. Now resource groups allow you to manage resources cleanly. That's the key word right there, cleanly. With a logical formation, you can create, replicate, organize, manipulate, and dispose of resources seamlessly. So dispose of, as quick as you can create a series of resources, if you have a similar project for a different client, you can replicate those resources At the same time, you could also delete them cleanly. You could get rid of all of them very cleanly, and you won't have to inherit any other costs, incur any other costs once you're through with it. It's good for organizing, it's good for replicating. We talk about that, and you can also manipulate the resources and the data that you have in those resources as well. So that's one of the core benefits of the resource group. Now, when we talk about resource group sets, um, sets the foundation for role-based access control and group level role-based access control. I have not spoken about role-based access controllers yet, but in a nutshell, I'm going to give you an high-level idea as to what it is. So let's say, for example, you have a group of employees that you want to manage your company. So you have a management resource group, and these are all your managers. You might want to give them access to an employee, say for example their payroll file, so they could set up their salaries, their payroll at that high level. So you will give them access based on their role as managers as a group. So that's a good idea and a good way to understand role-based access control until I talk about it in more details. So that's an high level understanding of what a role-based access control is. Now, you're able to set budgets and track costs. I explained that if you're working for a client and you want to be able to track the costs associated with the work you're doing for the client, you could use this. If you want to set a budget for that particular project, you could use a resource group and assign the budget to it as well, and you're able to manage it cleanly. Again, that's a key word right there. Now, let's look at another benefit of the resource group. Resource group cannot be intermixed. It cannot be nesting. It cannot be a part of another group. And again, it's the same ambiguity you would end up with as if you were able to create your own pairing in Azure regions. So you cannot nest your resource group. It will take away the cleanliness that you're trying to maintain. And that's why I keep coming back to the word cleanly at the top. So you can use resource group for a lot of reasons, and it has a lot of benefits. I just explained two or three so you could get a good understanding as to how resource groups work. Now, beware, there are three ways you can create resource group or most resources in Azure for that matter. You could create a resource group through the portal that I just showed you. You can create a resource group using a command line interface, and you can create a resource group also using the PowerShell script. So what I'm going to do, just to give you a general understanding, I am going to go back into Azure, and I'm going to create a resource group for you using the CLI or the Azure command line scripting, so you could get an understanding of how easy it is to create a resource group. Again, in addition to that, I want you to understand that the portal is not always the best way to create a resource. And when we talk about ARMS template and infrastructure as a code, you'll understand the benefit of using CLI or PowerShell. I'm not going to get into it right now, but I want you to know that the resource group, even though it's a graphical user interface and it's very user friendly, it's not always the most ideal way or the most ideal tool to use to create a resource. So let's take a step now and pause, and let's go and try to create a quick resource using the command line script in Azure. Okay, so let's go over to Azure and take a look at how easy it is to create a resource group using Azure. So what I want to do, I want to just copy this quick CLI, and then we want to go over back into Azure. And what I want you to understand is that the command line, it's right here. This is your Cloud Shell right where the browser is, and you want to click on it, and it's going to load and connect to your Cloud Shell for you. It says succeed. It's connecting to the terminal, and in a second you'll be able to see your Azure resource. There it is. So all I need to do to run my command line script, I want to type AZ, I want to type group create, and I want to give it a name. It's called demo resource group. I'm going to change this name, and I'm going to refer to it as our AZ It has to be one word. hmm I'm going to change it to our AZ resource group. Hold on. I think I destroyed the integrity of that. Let me repaste it. Okay. I'll do just that. I wasn't paying attention to the browser at least. Now let's move down. I want to change this name to our dash AZ dash 900 dash resource group. One word. Okay, so let's get rid of the extra files like that. And I want to use the US. I don't want to use West. I want to use East. So I'm going to do East US. And that's it. That should do it for you. So let's get back out and just run this CLI script and see what happens. Okay, it says succeeded. So now I'm going to refresh and see if I have that resource. And if I do, it should show you how simple it is to create a resource in Azure. Let's close the command line and we're going to check and see if our resource group was created. Okay, so there it is. You're able to see the resource group that we just created. Our resource group, it's right here, and it's created in the, no, it's not the US West, right here, US East, and it is created for us. So you get an understanding of how simple it is to create resources in Azure using the resource group. All right, so let's get back to the course outline and let's continue going through the tutorial. So we have an understanding of what the resource group look like. We're able to go in and create a resource group and we get an idea of what the client side bash script looks like. Now let's talk about Azure Subscription. I spoke about it briefly as well, and I mentioned that you need a subscription to operate in Azure. You're going to need one when you get to this point because you're going to need one to be able to go in and run the resources in Azure. Now a subscription in Azure is really your main account. It's a little confusing the way Azure refer to subscription because they use the term loosely and you have to kind of figure it out implicitly to get an understanding of what type of subscription they're talking about. You will need either a free or a paid subscription, like I said, in order to use Azure. But let's take a deeper look at subscription. Once you have a main account or a subscription, you can have many sub-subscriptions for billing or for departmental purposes in Azure. And a general overview is this diagram right here. This is your Azure main subscription or your main account. And then you could have a subscription for development, a subscription for testing, or a subscription for production. So you would end up with 3 separate subscriptions, but they all would fall under your main account and they would get billed through your main account. Now, Azure uses a word implicitly and it can be very confusing, again, like I said at first, but when you use it in context, you'll get a better understanding of how it is used. Now, let's look at the management group. It's another type of organization that you could use, and this is at the highest level within Azure that you could use for grouping. So the Azure management group is at the highest level. It controls where you can manage access. It's a control where you could use to manage access policies and compliance across all your Azure subscription in the domain. This is your root management group that your root account would be tied to. And when we talk about management group and we talk about policies and compliances, when we get down into chapter 4 and 5 and 6, you'll understand it a lot better what are compliances and policies. Now the root management group sits at the top of the hierarchical chart and all subscriptions within the management group inherit their powers from the root group. So when you talk about subscription, your resource group would fall below your management group. So you at least get an understanding of what I'm talking about as it relates to the hierarchical layout. Now, if you don't, here's a visual illustration. This is your management group. This is your manager right here. So their management group will sit right there. Then you'll have your subscriptions. Your different subscription group. You could have one for development, one for production, or one for testing. And then these are your resource groups, which we talk about. So you could have your different resources within those groups. And then these are your individual resources at the bottom of the barrel right here, laid out individually. So you could apply rules and role-based access control to the resource. You could apply it to the group. You could apply it to the subscription. Or if you want, broad-based enterprise control, you could apply it to the management group. And when we drill further down in Azure and we talk about Azure Blueprint, you'll understand that you have an even elevated layer of control that you could apply at the management group with blueprints. So this should give you a good understanding of how management groups work. Here's a broader management group, same concept, your root management group, but on a broader horizon in a bigger organization. So it's a lot more detail. Same concept, so you get an understanding of what management groups are and how they work. Now let's look at the benefits of management group. The Azure Management Group allows you to create policies and compliance rules that all sub-management subscription below the root management group can use as a child inheritance. Yes, I saw the typo there with the CAM, and now you know it's supposed to be CAN. Now, Azure Management Groups allow a single point for role-based access control. And I give you an example as to what a role-based access control is. If you have your managers and you want to give them control to the HR files for payroll for your employees, this is what the management group, you could set it at that level as well, and you could use it in that situation as well. So rather than assigning an individual role-based, let's for example, to your employee, say you have a set of employees that are your line managers and they're your supervisors. Now you want all your supervisors to have the same rights and the same privileges on the system. You would set your role-based access control as the manager at that level to the subscription group for all your supervisors. So that should give you an understanding of what the benefits for management groups are. If you want to provide a certain access to many subscription, the management group is the best place to make that broad assignment in Azure. So now you should have a good understanding of what the management groups is, what it does, and how it works. And also the management group gives you enterprise level, large scale management overall on all your Azure resources as well. So you could set roles on your devices, you could set it on your application, and you could set it on your individuals. Now let's move along to look at the Azure Resource Manager. Now the Azure Resource Manager, it came up before. When we talk about the command line scripting a moment ago, we mentioned Azure Resource Manager real briefly. Now, the Azure Resource Manager is really a powerful tool, and it's really a piece of code that is written using, it is in JSON format. You could use it to roll out an entire infrastructure. So if you recall, I said it's not always the best place to create a resource is not always through the portal, even though it gives you this nice graphical user interface. Now, if you want to roll out like 1,000 different virtual machines, you don't want to do it through the portal. It will take forever. That is what your Azure Resource Manager is for. You want to use the Azure Resource Manager to create those for you on the fly programmatically using codes instead of using the Azure Portal. Now, the HARM provides management layer that enables you to create, update, and delete resources in Azure account very easily and cleanly. Again, the word cleanly. And you're able to do that once you're familiar with the Azure process. Now, there's something else I want to explain about the Azure Resource Manager before I go any further. You can use Azure Resource Manager as a tool. You could use it through your API using your SDKs, or you could route it through the ARM. But anytime you try to get access to a resource in Azure, it goes through the Azure Resource Manager. The Azure Resource Manager has to authenticate you and give you access to that resource. So if you're using the cloud, if you're using a Windows PowerShell, if you're using the Linux or the Mac PowerShell, it goes through the SDK. If you're using the REST client, they're all going to go through the same process. The resource manager is going to authenticate you, and then it's going to lead you on to the actual resource that you want to get access to. So you need to understand that all requests for resources goes through the Azure Resource Manager template. And you also want to remember that these are JSON files. They're created, the Azure Resource files, they're actually created in JSON format. Now, ARM has plenty templates, and there it is. It's built in JSON format to deploy resources programmatically at scale. These templates are available in the marketplace, so there's a lot of predefined templates. So, for example, if you want to create a certain kind of virtual machines, use in Linux, there's a template. A virtual machine in Windows, there's a template for that. There are templates out there for a lot of different things in Azure, and I want you to understand that. Now let's take a look at the benefits of the Azure Resource Manager in Azure. So you have a rich set, a collection of predefined open source declarative JSON templates in Azure. Declarative JSON templates, well-defined templates. You also have control over all your resources at the group level versus at the service level. You also get consistency in deployment cycle when you're deploying a solution. You get defined resource dependencies so that they're deployed orderly. So if you have one resource that's relying on another resource, you'll get them deployed in order so there won't be any inconsistencies. You get native role-based access control of resources being deployed with the ARM. You also get tags. We haven't spoken about that as yet, but you will be familiar with tag very soon. A tag is the most granular form of organization that you could get within Azure. When I talk about tag in details, you'll understand it, how it's organized, and how you can use the Azure Resource Manager and the Azure Management Group to actually enforce tags in Azure and use tags in Azure for organizing. Tags, you can use tags to merge similar resources to simulate billing and get costing. So again, it's another tool that you have at your disposal, but it's the most granular and the most dynamic tool that you could use in Azure for organization. Remember that. So when we get back to tag, now you could use it to protect critical resources using locks. It's another term that I haven't touched on as yet, but locks is the ability for you to secure a resource and prevent it from being deleted by mistake, inadvertently in Azure. You're able to put locks on it, so it forces you to have to remove the lock before you can delete that particular resource. Now let's see if there are any more benefits in the Azure resource pane, and I don't think there are any more benefits. All right, so we have come to the end of this particular chapter, and we are going to move on to the next chapter. Okay, so I promised that for the next session I will go over it with you. So we're going to be talking about virtual machines in Azure. I'll define virtual machines so you understand it a little better. And we're going to talk about Azure App Services. I'm going to talk about Azure Container Instances, Docker Container, Kubernetes Services. Then we're going to be talking about Kubernetes Services. Then we're going to be talking about Azure Virtual Desktops. I'm also going to be talking about virtual networks, VPN gateways. I'm also going to be talking about virtual network peering. I'm going to be talking about Express Route. I promise you I would talk about it in more details. We're going to be talking about storages, blob storage, disk storage, file storage, and also storage tiers in Azure. Then I'm going to move on and talk about databases, Cosmos DB, Azure SQL Database. We're going to be talking about Azure Database for MySQL, Azure Database for PostgreSQL, and SQL Managed Instances. And then that will complete that chapter. Well, not before we talk about Azure Marketplace as well. So let's go ahead and get started and talk about virtual machines. So Azure Virtual Machine or virtual computers you can use to create Azure Virtual Computers you can create very easily and quickly to emulate a physical computer. You can configure and provision these virtual machines using an hypervisor, a technology provided for you in infrastructure as a service by Azure. So if you're coming from a Windows background and you are familiar with virtual machines, you use an hypervisor with Windows Server, you should be familiar with virtual machine in Azure. It's exactly the same concept, except you're accessing these virtual machine over the internet using your browser at the HTTP OSI layer 7. Now, in addition to virtual machine, we have what we call virtual machine scale set. It's very similar to just scale sets in Azure. This is where you group a bunch of resources and you can use them to scale out your resources. Now, with virtual machine scale set, it's a part of elastic scaling. We talk about it at length when we talk about elastic scaling, and I use the example for the Olympics and the need for 1,000 computers real rapidly on the fly. You were able to scale them for me massively. You remember? Well, this is the virtual machine scale sets in detail. It's a group of similarly configured virtual machine, and remember the term similarly configured. They're the same type of configuration, same software is on it. Everything has to be the same for it to be on the scale set. Now, virtual machines that you can use for load balancing in Azure. So if you have a need for a lot of virtual machine, you could create them and Azure would do auto scaling for you. It would scale in and scale out based on your need for those virtual machine. This tool allows you to scale elastically in a real aggressive and rapid manner to meet demand, and you can deallocate and scale back when those demands subsided and you no longer need those resources. So you get virtual machine skill set, you got it in detail. I mean, you got an overview before, now you're getting it in a lot more detail. So let's look at virtual machine and skill set together as a benefit. There's zero capital expenditure and low operational costs. So if you need 1,000 machine, you could scale them out a lot easier using scale set. Now with virtual machines, you get skill set with load balancing and centralized control. You can add them at once and you could delete them at once. So you got that powerful control. Virtual machine skill set demand less configuration and routing complexities. So let's say, for example, you need to scale 1,000 computers for the Olympics. In the traditional data center setting, you would have to get a budget, you would have to order those computers, it would take a couple of weeks for them to be shipped to you. You would have to open the boxes, you'd have to break them down, you'd have to provision them, you'd have to add them to the network and do your configuration. Then you'd have to install your software on it. It gives you an idea the amount of resources you would need to do that, both manpower and technical resources. In Azure, you could do the same thing with a single person, and it's done within a matter of hours, if not minutes. So that's one of the benefits and power of the scale set. In addition to that, virtual machine and scale set, you get massive and rapid scalability. We go over that a lot. I'm going to browse by it. VM scale set, you get great solution for testing scenarios. When we talk about Dev Test Lab down in DevOps, you'll understand how Dev Test Lab is able to get all the machine and resources it need in a real quick fashion. It's scale set. It's they using the virtual machine scale sets again. Scale sets also is good for migration when you migrate from your on-prem solution into the cloud. It's a very streamlined process. You also get disaster recovery with high availability and it's done for you seamlessly. So that's some of the benefits of virtual machine scale set. Look at the benefit. Another benefit you get is auto scaling. I think I mentioned that before. You get auto scaling so you don't have waste. When we talk about cost management in Azure in chapter 5, you will see the benefit of auto scaling. It helps you to manage costs because you're not keeping idle resources around. And again, it's different from on-prem where you'd buy this large server and it will take you about 4 or 5 years before you fill it up or use it up or use up all the resource that you purchase. With scale set, you get centralized management and consistency again across the board. All right, with scale set, you have load balancer for both your basic layer 4 traffic distribution and advanced layer 7 traffic distribution and TLS termination using Azure Application Gateway. When we talk about Application Gateway, we'll talk about load balancing again and we'll talk about scale set. You get benefit of scaling. Sometimes, depending if you're using managed or unmanaged disk, you could scale up to 1,000 VM in a single scale set, and that is why I use 1,000 as the example. I didn't go over. I didn't go under. I'm giving you an example of the maximum amount of VM you could add to a scale set when I did that. So it was done purposely. So again, you could use a managed image or you could pull your images from the marketplace to help facilitate the VM creation when you want to do that. You could also use the compute gallery images to create the images that you need for your virtual machines for Windows or Linux. Now let's see what else we got here. So that's it for virtual machine skill sets. Let's talk about containers and container instances. So a container in Azure is a lightweight virtualized environment like a virtual machine, but it has a lot more flexibility, it's a lot more dynamic, a lot more fluid, and it's a lot easier to create. Now let's look at some of the benefits. With container, you can simulate multiple operating system on a single virtual machine instead of being restricted to one operating system to a virtual machine. So you could create several containers and each containers could have their own virtual machine, and it's a lot easier to create than a virtual machine in Azure. Further to that, you can run multiple instances of a containerized application using a separate operating system for each on a single virtual machine. So with a single virtual machine, you could have run several containers on there. Each container can have their own operating system, which is which is directly tied to the particular software that you want to run. So you could be running Linux, you could be running Windows in different containers based on the application need. So it also provides for huge upfront cost saving when you're able to virtualize in that manner using containerized services. Unlike a VM, you don't need to manage the OS in the containers either. Now, think of VM and skill set as a rapid solution to a change in demand, a change in need. You need 1,000 resources, so that skill set is a solution. Now, if each of these employees at the Olympics that you're going to provide 1,000 computer for, if they're running 1,000 different software, you understand how complicated it is. Now consider the containers as a fluid solution to a situation like that where a demand for diverse changes is needed. So again, VM skill set, a rapid change in solution and a change in demand. And if you have a change, a diverse change for different solutions, containers are your solution for that in Azure. Now, Azure container instances run on Windows and Linux alike, and you understand that they both would be using the VM. Now in Windows, Docker is one of the most popular container engines, and the Docker engine is what Microsoft uses, Docker as a service, in Azure to do their containerized application services. It is your containerized solution of choice in Azure. So remember that, understand Docker and Docker instances. Now let's look at containers on a broader scale. We're looking at Azure Kubernetes Services. Now Azure Kubernetes Services is a mainstream container orchestration, a containerized automation service that is built on the open source Kubernetes system platform. It is designed to solve complex orchestration problem. Kubernetes are like scale set. They allow you to scale massive amount of containers systematically with one centralized point of control, the same way you would scale multiple virtual machine in a scale set. So that's your Azure Kubernetes services. It gives organization great control over containers, and it is recommended in large scale organization and operation. So if you have massive amount of container needs, Azure Kubernetes Services your solution. The containers are made possible by microservice architecture, and remember I spoke to you about microservices before, and I promised you I would look at it in more details. We're getting closer and closer to that now as we're using the term more and more. So again, Azure containers are made possible by microservices. Microservices are just logically layered architecture like presentation, application and business rule and data layers in a web application with an agile approach. It's agile. You can do services in small bits, microservices, and they're similar to the S in the solid principle. I think I mentioned that somewhere else in the training. Yes, in the solid principle, the S is a single responsibility. It has one task, one purpose, one focus. It's clean and easy to manage and easy to understand. So we'll talk about microservices some more when I talk about Azure Service Fabric. So there you got it, Azure Kubernetes Services. Whether you intend to use the superfast Docker engine or more expensive Kubernetes as your orchestration in Azure, they can both start, stop, and scale out application instances in a really rapid and massive fashion. So that's your container services. I hope you understand the difference between the two. And now we're going to be looking at Azure App Services. Now, with Azure App Services, you're running this at the web browser level, HTTP OSI layer 7. It enables you to quickly build and host application, mobile backends, RESTful APIs in a programming language of your choice without managing the infrastructure needs behind. So again, it's another form of your serverless computing. Azure App Services offers auto scaling and high availability, and it supports both Windows and Linux development and enables automation deployment from GitHub within your GitHub. When we talk about Git actions later down, you'll understand the power of app services and how you could intertwine it with the Azure App Services. Azure DevOps, we'll talk about that as well, and we'll talk about the GitHub repos and how they intertwine and ties into your core Azure services. Okay, so let's move on to the next piece. Now, you can use Azure App Services. There's different ways that you could use the Azure App Services. You could use it with your Windows apps. You could use it with your Linux apps. You could use it with your Docker containers with both Windows and Linux. You could use it with your functions. We talk about functions. And you also can use it with your Logic apps. We're going to be talking about both of them as serverless computing services when we talk about functions and workflow orchestration further down in the course. Now let's take a look at the Azure service fabric that I spoke about before. It's your microservice king. It's really your microservice platform that you want to really pay attention to. It's not a part of the course outline, but I realized that there were questions on my exam about Azure Service Fabric. So I wanted to include it in the course for you really quick. So Azure Service Fabric is a tier 1 distributed system platform that makes it easy for you to package, deploy, and manage scalable and reliable microservices and containers. So again, when we talk about microservices and containers, Azure Service App can help you with deploying these packages. Now, Azure Service App powers many Microsoft services today. A lot of them you're not aware of, but your Azure SQL database, your Azure Cosmos DB, Cortana, Microsoft Power BI, Microsoft Intune for managing your your device registration, Azure Event Hub, Azure IoT Hub, Dynamics 365, Skype for Business, and many other services use the Azure Service App apps in the back. I'm sorry, Azure Service Fabric in the back end. So it's really, really powerful tool. You want to understand it and you want to understand what it's used for, just in case it pops up on your exam the way it did mine, even though it's not in the course outline. I think it's because it is so powerful as it relates to microservices, and microservices is a big part of what we're doing with functions, with the app service logic, and the entire continuous orchestration and continuous integration processes. In addition to that, the fact that it can be used to create packages and deploy those packages and manage them in a scalable and reliable manner is probably the reason it is incorporated in it. But I'm presenting it to you, you get an understanding. Here's your developer's machine. You can use Linux, as you can see. It's running in Azure, it's running on premises data center, and it's running in, you can run it on other cloud spaces as well. You get your order scaling, you get your DevOps tooling in the service fabric as well. You get your health monitoring, you get your programming models, you get your automation and orchestration. It's always available. This is your Linux, and this is the lifecycle management with your DevOps machine. Really powerful tool. I want you to understand it. Now, Azure Service Fabric also addresses significant challenges in developing and managing cloud native application in public or private cloud. So you want to understand that as well. Okay, let's take a look at what else we have in. We're going to be talking about the Azure Virtual Desktop next. This is probably the only thing that was updated in the November version of the course outline. They changed it from Azure Windows Desktop to Azure Virtual from Windows Virtual Desktop to Azure Virtual Desktop. It is the same virtual desktop you're familiar with on premises in your data center. Now, Azure Virtual Desktop, Desktop as a Service, DaaS, is a remote terminal emulator to your virtual machine. So it's a terminal emulator you could use through your web browser. It can only be configured on a Windows OS, but it can run on Windows, Linux, Macs, Android, or any other operating system or platform once it's created. Now, Azure Desktop Client works across platform to execute, publish Windows apps. Azure Virtual Desktop is containerized services and that uses FX Logic to manage profile. Each user on the Azure Virtual Desktop is managed using the Azure Active Directory. Now, Azure Virtual Desktop uses reverse connect technology where the inbound ports to your host session or VM is closed by default. This connection type is far more secure than the remote desktop protocol. Now, Azure Virtual Desktop abilities, it runs full desktop virtualization without any gateway servers. It has limitless virtual desktop to meet any workload demands. You use Azure Gallery to bring your own image in for testing and production. It's cost saving with multi-session resource pooling with Windows 10 Enterprise. You also get to carry an individual ownership through personal persistent desktop. You get multiple ways to configure an host pool to host, create app groups, assign users, and publish resources as well. You can publish remote apps from one host pool, manage resources in groups, or individually from a remote desktop. You can use it to use built-in delegation across the assigned roles and collect diagnostic information and troubleshoot those. Managing only your remote desktop and not the entire infrastructure. So these are some of the benefits that you get from using the Azure Virtual Desktop. You can also manage your remote desktop and not their roles as you would using the remote desktop services. Now let's look at the Azure Virtual Network. Now the Azure Virtual Network, or VNet as it is called, is actually your internal network service in Azure, and your tool that you would have. It's similar to your networking tool in an on-prem situation. Okay, So we want to get a good understanding of the VNet. Let's take VNet. It allows you and your resources, such as your virtual machine, to communicate securely with each other on your private network. So that's the main purpose for your virtual network. Now, a VNet is similar to a traditional on-prem network. I mentioned that infrastructure, but with greater scalability. I'm sorry. So higher availability, greater segmentation, and isolation strategy. So this is different from your on-prem. These are the notable differences. You get greater scalability, higher availability, you get great segmentation, and great isolation strategy that you could employ as part of your network security posture as well. Now, with a VNet, each VNet must have a unique name. That's one of the requirements to use a VNet in the cloud. It's the same as in the on-prem situation. And you need to have a classless interdomain routing or your SIDR range. Your SIDR range is a predefined list of IP address that must be unique on your network or VNet. Otherwise, you're gonna end up with conflicts. Now, your subnet or logical partitions of an IP network. So they are part of your VNet, but they're subsections, and it's what contribute to your segmentation and isolation that we spoke about before. So it's smaller segment. You can break up a large VNet into smaller subnet network, and you do that for security reasons. So you could have more control over your network. You could have more confidentiality, isolation, with isolation and segmentation. Now let's take a look on understanding SID range. I'm going to go over this really quick. It's not really that important. I just want you to understand that we're using a SID range of 16 right here, and the lower the SID range is, the more IP address you could generate. So with a SID range of 16, you could assign 65,536 IP addresses. I gave it a range 10.0.0.1, and it goes all the way to 10.0.255.254. Those are the ranges of IP address that you would have at your disposal. Now the IP address and the SID range of 10.24 is only 256 IP addresses that you would have at your disposal. So I just want to show you the difference between the two. And then I want to show you the subnet must have a smaller SID range than your VNet. So it means that you would have to use a larger number for your subnet than you would have for your VNet in order for it to work and you not having IP conflicts. Now pay attention to the assignment to avoid conflicts. If you don't do that, you're going to get the error that there are conflicts, and sometimes you might not get the error until it's too late or it's in production. Now a network SID, this is just an example. Again, we're going over. I don't want to put a lot of effort onto the SID range, so I'm just going to give a brief overview so you could look at it. So it said, for example, you're creating a VNet. This is your SID range. You're using 16. And if you're creating subnet for your web applications or for your web server or a subnet for your SQL server, you want to distinguish between the two by using the different IP ranges. So this is 10.0.2, and then I'm using 24, and this is 10.0.3, and then I'm using 24. So it creates a different series of IP addresses, and there would be no conflict in these SID range when they are created. So this is for you to understand not just the concept required for the exam, but to understand how the SID range work and how to avoid conflicts in your setup or in your shop. And this chart is just a general overview of why the lower the SID range, the more IP address you get. So with a SID range of 8, you have up to 16 million IP addresses. SID range of 16, you have 65,000, and with a SID range of 30, you only have 2 IP addresses. So that is not germane to the exam, so I'm just going to browse past that in a quick manner. Now let's talk about the Azure Virtual Network diagram. So this is your subnet in general. This is your public internet. This is Azure. This is your public IP, your client-facing IP. This is your front end subnet. This is your back end where you have your database. It's private. This is your general VNet network, and this is your public and your IP address with your SID range. Now, public IP can reach the internet. You need to understand that. Private subnet should not. So your web server should and applications should be resided on a public subnet, but your database should not. Now let's move on to virtual network diagram. So here are some of the core benefits of using an Azure virtual network. Now, I'm sorry. Now to route network traffic, you're able to route network traffic using a specific table, the subnet table. Filter network traffic using your network service group. We'll talk more about network service group. It's like an internal firewall. We'll talk more about it later on in details. Express route, we talk about express route connecting two sites together in a really fast and efficient manner. So you use it to connect your on-prem with Azure. Peering resources together over the VNet. So we talk about VNet peering. You're able to do that with express route. We talk about isolation and segmentation of your network subnets for better security, less access with isolation and segmentation, easier to manage. We talk about internet communication using inbound, outbound IP addresses. We also talk about communicating between Azure resources internally. All right, so let's talk about VPN now. So VPN are trusted conduits of connections that operates over an untrusted area of the internet. Now, we're not saying that the internet is not trusted, it's just not as safe as the layer that the VPN uses or the technology that the VPN uses. So when you do a VPN connection, it passes over untrusted areas of the internet, connecting one or more points to one or many points. Now, the transfer of data that passes over a VPN is encrypted and it is routed through a private tunnel as it crosses over the internet. Each VNet can only have one VPN gateway tunnel. The dedicated gateway can then access endpoints or your devices, and this is an example of the setup of your VPN gateway. There's encryption and packaging and decryption going on right here, and it's just an overview of two different endpoint connecting an endpoint to a site. um, that's just the layout that we're looking at right there. So it's important to understand this is going to be on your test site to site connection. Remember, site to site, on-prem to your virtual network in the cloud. That is referred to as site to site. Point to site is when you're using your VPN and you're connecting to the site. That's an example of point to site. And then you have network to network when you're merging two network together with express route. So understand the difference, what site to site, what is point to site, and what is network to network. I can assure you this will be on your exam as well. So here is a general overview of how the packaging is done when you use a VPN. Internet Key Exchange is responsible for a part of it, and the Internet Protocol Security is responsible for another part. IKE construct the transaction contract between the two endpoint, and then its ISPEC is responsible for encrypting it. So you get an understanding of how the data work as it passes through as a VPN. Now let's take a look at virtual private network. You can deploy a virtual private network in one of two ways. You could use policy based or you could use route based. Now the core difference between these types is how the data that you transport will be encrypted. In Azure, both type uses pre-shared keys for authentication and authorization. Both the policy and the route-based types uses Internet Key Exchange IKE and the Internet Protocol Security ISPEC. So IKE again construct the transaction contract between the two endpoints, and ISPEC is responsible for protecting and contracting the and contract by encrypting them at the source point and the destination point, decrypting it at the end of the tunnel. So that's what the security in the middle does that I was pointing to. Now, policy-based VPN gateway uses a static IP address for routing. You don't always have that luxury. Now, the route-based VPN are best when defining which IP address are behind each tunnel is too cumbersome, or you are on-prem and you use a route-based VPN instead. Now, ExpressRoute, we talked about it before, is used to connect two sites together. Now, this is a super fast connection between your on-prem and public cloud resources um, with the help of a connectivity correlation provider delivering speeds between 50 megabits and up to 10 gigabits per second. So this is not your ordinary internet connection. It's a special site-to-site connection that you would use for ExpressRoute. And this is an overview of ExpressRoute in motion. So you're looking at the Microsoft pairing, and you're also looking at the Azure private pairing. But this is a layout of ExpressRoute in motion, and you're looking at the different conduits and how it actually works. Now, understand ExpressRoute relies on layer 2 data link with node-to-node communication between the two nodes on the same network, and layer 3, L3, the network layer, which provide addressing and routing between the nodes on a multi-node network as the driving force behind ExpressRoute. So if you're connecting your on-prem to the cloud, you want to use ExpressRoute. It's a really fast and efficient way to connect your on-prem data site to the cloud. Now let's look at the benefits of ExpressRoute. There are several benefits for using ExpressRoute. One, you get low latency, layer 3 connectivity between your on-premises and network in Azure. You get connectivity to Microsoft Cloud services across all regions in a geo region. You also get global connectivity to Microsoft services across all regions with ExpressRoute Premium as an add-on, so that's not your standard service. You get dynamic routing between your network and Microsoft VPN BGE as well. You get built-in redundancy in every pairing location for high reliability. You get connected uptime SLA, connection uptime SLA. You get QSA support for Skype for Business solution. Okay, now we're going to take a look at storages real quick, and then we should be wrapping up this particular chapter. Okay, so let's take a look at storages. We're going to look at containerized storages, otherwise known as blob storages. So Azure Blob Storage is a containerized object-oriented storage solution designed specifically for the cloud. If you're a developer, you understand the difference with the object-oriented type of storage. Now, blob storage can store massive amount of unstructured, non-specific data with non-specific format for direct web application access and usage. So you could access the blob object over the internet. That's an option. Blob objects can be accessed. Okay, that's exactly what I was talking about. Yeah, you could access it at the OSI level 7 HTTP and S layer using native REST API, Azure PowerShell, Azure client-side interface, or Azure Storage Client Library. With blob storage, you won't need to provision storage. You can just scale elastically, infinitely, so you have unlimited access to data using blob storage is what that is saying. You can use blob storage to do the following thing: to post your files such as images and documents directly to the browser. You could use it for holding files for distributed access from any resources. You could use it to stream videos and audio files over the internet. You could use it for real-time application login. You could use it for cold and hot storages, backup, restore, and disaster recovery. So you see, it's very dynamic. It's a really popular form of storage, and I think it's a type of storage that Microsoft Azure wants you to use. Now let's take a look at what else we have going on here. We're going to be talking about blob storage. Oh, blob storage has three storage waterfall models that you could use. So it's talking about the account, the container, and the blob portion. So these are the different portions that actually make up the blob storage object. Now the following diagram shows the relationship between these resources. I'll show you the illustration in a few. In the meantime, this root account is a namespace for the blob storage and with one or many containers inside the name. So there's a namespace for the blob storage. You'll need a fully qualified domain name for the namespace to access the blob storage. So it seems as if it would have three sections: an account, a container, and a blob. So if Sally is the account, she could have a container, or which is like folders within a folder. You could have a picture folder and a movie folder. You could route all your blobs, your image blobs, JP blobs to the blob, and then you could have your AVI blobs. So that's an overview of what the blob storage look like. Azure Blob Storage types: you have the blob blocks for text and binary storage. Then you will have the append blobs or blocks, good for appending abilities for things like logging. And then you'll have the page blob for random storage. So that's your Azure Blob Storage. Now take a look at Azure Disk Storage. Azure Disk Storage is virtualized storage used with Azure Virtual Machine and VMware solution. Azure Disk Storage offers high performance, scalability, high availability, security, and durable block storage for your mission critical business solutions. So it uses this for mission critical solution instead of your blob storage. The Azure options include four choices. You have Ultra Disk Storage, Premium Disk Storage, Standard Disk Storage, Standard SSD storage, and standard HDD storage. With this managed disk tier method, you only need to select the disk type and size you need and provision it for use. So all these disk tiers that I spoke about, it's available under the managed disk tier system. Now, Azure recommend using premium solid state drive as your operating system drive. They're very low latency and they're very fast. Understand that you cannot use Ultra Disk for operating systems. Remember that. I'm going to repeat it. You cannot use Ultra Disk for operating system. It is going to come up again, and you should remember where you heard about it first. Now, you should only use them for storing high demand data. So Ultra Disk are created as empty disk. Maybe that's one of the reasons you don't want to use them for OS storage. And there are other reasons as well. There are other limitations. So again, you want to use Ultra Disk only as prescribed. Now let's take a look at Azure Disk Storage and look at the different type of storage. This is your Ultra Disk, and it's a hottest type of disk. It's a SSD hot. Now you have your premium disk is SSD hot. I'm sorry, this is the hottest. Now you also have your standard SSD, which is the SSD warm, and then you have the standard hard disk drive, which is HDD cold. So you'd use these mostly for archiving purposes. Now here are the different usage scenarios. You would use these for ultra high intensive transactions and heavy workloads such as your database. Similar situation, you would use your hot SSD for production work, performance sensitive workloads. You use the SSD warm for your web servers, lightly used enterprise application, and development and testing. So if you're faced with a situation as to what disk you should use for development and testing, it's your warm SSD, standard SSD. You don't need premium or ultra disk for testing. Standard HSD is used for backup, non-critical, infrequent access. You could turn these disks off when you're not using them to save energy and spin them up when you need them for access. Now let's look at Azure File Storage. Now Azure File Storage is same as the file storage that you would use in Windows. It allows for high available network file share. You could use it for your file share on your resource platform using standard server message block SMB protocol for reading and writing access. Now, REST interface access mode or the storage client libraries, you could use them for that as well to read files over the internet. You can mount Azure File Storage concurrently using Azure or doing an on-premises deployment of Windows or Linux or Mac OS. So you could use it from Mac OS as well with your file storage. That's the Azure File Storage. Now, Azure File Sync, you can also cache files near their endpoints for faster access latency. The end result is Azure File Share. Multiple VMs can share the same file concurrently with reading and writing access abilities. So you have an understanding of what you could use a file share for is similar to what you use file share for in Windows. And there you have it. You could use it in the cloud as well. With Azure File Storage, you can securely access files anywhere on Earth with a shared access signature SAS token with a lot less complexity than you would do before or than you would do with a legacy system on premises. Now, this is an example of the SMB at work, and it's showing you access across different geographies in different countries. Now, Azure's benefits, let's look at some of the benefits of the file storage. It allows seamless migration of on-prem file shares to Azure. You also get a single share that can be accessed by multiple virtual machines. Development team can use Azure File Shares to access files, tools, and utilities across team, giving them the same access to the same files at the same time. So you get simultaneous access remotely for your development team with Azure File Share. You could also use Azure File Share to capture resource logs, matrix, crash dumps, or any other tracking and tracing data that you can manipulate at a later date. Now, geographic Azure files are encrypted at rest. You want to remember that by default, but file shares takes care of the security and the encryption for you during transit. Now, let's go back over that. Geographic Azure files are encrypted at rest by Azure File Share. Now, SMB takes care of the security and the encryption for you in transit. That's a lot clearer. Okay, now let's look at the storage tiers in Azure. Now, Azure Storage Tier, and again, these are for managed disk. It offers three storage tiers to store data in blob storage. Now you have a hot tier, which is the cost the most to store and less to access. It's used for high demand workload. So again, the storage is the most costly. You have cold access where the data is at rest for 30 days or more. It costs less to store, but it costs more to access. I'm sorry, it costs less to store and more to access. Yes. Next we have is the archive tier. It's a coldest tier and it's stored with high retrieval fees. So it costs you more to access, but it's still cheaper for the tier for long-term storage. So what you do, the access costs more because you have to spin up disk, you have to turn them on and get them online. It takes more time to access, so I'm figuring that it takes more time and more resources, so it costs more to access but less to store. Now let's look at some other storages that might come up as point of interest. We have the Azure Queue Storage. This is a service for storing large numbers of messages in a queue, and we already know what a queue is. It's queuing up data for future use. It's not doing it synchronously. Now, you queue up storage with a limit. You access messages via authenticated calls over the internet. A queue message can be up to 64 kilobytes in size, and the queues are commonly used to create a backlog for back work processes asynchronously. Now, a queue is used for queuing up messages between applications. So it's not really real time. You understand what a queue is and you understand the concept behind it. Now, Azure Table Storage, it's a point of contention. A lot of persons believe that this is a database because it's using keys. It's a non-SQL database, but Azure refer to it as a table storage. And Azure Table Storage is a service that stores non-relation structured data, also known as structured non-SQL data in the cloud, providing a key attribute that stores with schemaless design. Now, access to this type of data is usually very fast, it's very cost efficient, cost effective for many types of application, and it's typically lower in cost than traditional databases such as traditional SQL databases such as Azure SQL. Now let's look at another type of storage, which is the Azure Data Box or the Data Box Heavy. This is a physical type of storage that allows you to store up to 80 terabyte of data that you could send physically between location. It's good for data migration. It is shipped through a service carrier from point to point. It's very secured, it's encrypted, and your data is pretty safe going back and forth from destination to destination. So this is a physical suitcase or carrying case that would be used to execute this service. Now, Azure Data Lake, this is a centralized repository for raw, unstructured data and big data storage. So if you're dealing with big data, Azure Data Lake is what you want to use. Now we're going to take a look at the databases in Azure, and this should wrap up this chapter. I know it's a long chapter. It was a lot of material to cover. It's probably the most exhaustive in all the chapters that we'll have to do. After this, the other chapters will get a lot easier. They'll be a lot simpler and a lot cleaner to understand. These concepts are very important, and it takes a really long time to go through them. Okay, let's move on. Let's look at we're going to be looking at databases now and the different types of databases. The Cosmos DB is the one I'm going to be talking about first. It's similar to the data storage that we just talked about. Except it's a fully managed non-SQL database, so you're not able to do query in it. But it can scale automatically without any latency leak. It's exceptionally fast. A Cosmos DB can handle super large key value pairs of data, similar to the table storage that I spoke about. And again, this is the reason why it's compared to a database, the table storage in most situations. So you can handle really large volumes of data using data pair. It's a non-SQL database. It scales really fast. It's exceptionally fast. So if you're looking for performance and scalability, the Cosmos DB with its rich blend of ready-to-use APIs such as the SQL API, Cassandra API, Gremlin API, Table API, and the Azure Cosmos DB API for MongoDB make Cosmos DB a serious heavy-lifting contender for super large amount of data. So there is your first option for databases. There are also SDKs and SQL APIs available in .NET and Java and Python and Node.js, which developers can also use to create their own solutions to work with the Cosmos DB as well. Next, I'm going to be looking at the benefits of the Cosmos DB. I talk about it being exceptionally fast. There are other benefits to it as well that I want to take a look at. Yep. So you get the guaranteed auto scaling with Cosmos DB, and that is elastic scaling. You scale in and out, and you get speed with the Cosmos DB. So if you're looking for a database, a non-SQL database, it's an excellent choice. Also, next benefit is you get global real-time latency and throughput burst. There's no leaks, no data leaks, no data latency leak using the Cosmos DB globally. It's exceptionally fast, and that is one of the key and core benefits of using the Cosmos DB in a situation where you want to handle unstructured data in large volumes. You also get simplified and fluid open source support for developers. I spoke about those before, so you get the benefits of using your own software, your own programming language. There's a lot of tools and SDKs that are available to support the Cosmos DB. You also get Azure Synapse Analytics support for deep analysis in Azure. So there's also support for that built in the Cosmos DB as well. You get business continuity at an exceptionally high SLA percentage at 99.999. That's five nines. That's exceptionally high. And you get this enterprise level security with the Cosmos DB as well. You also enjoy enterprise grade encryption at rest with self managed keys with the Azure Cosmos DB. You get a fully managed, cost effective serverless solution as well. You get integrated seamless you get integration seamlessly with any web, mobile, gaming, or ITO application with the Cosmos DB. So you can see it's really an exceptionally powerful solution as it relates to non-SQL database. Next, we want to look at the Azure SQL database. If you're familiar with SQL Server in Windows, then just think of it as the same exact thing that is just lifted up and inserted into Azure as a solution. It's really Microsoft SQL Server offloaded into the cloud as a fully managed SQL database with a fully managed database engine that you can use for queries and analytics. There's a lot of services that you could provide that can be provided using the Azure SQL database. SQL database provide domain specific database administration with optimization ability on the platform as a service backplane. SQL database is extremely dynamic and it can handle both structured relational data and non-relational structures such as graphs, JSON files, spatial files, and XML formats. So it's very dynamic in the type of formats that it supports as well. Now, with SQL database, you get tiered servicing, multiple source type, you get deployment option and compute sizes. You can deploy one contained SQL database engine as you would outside the cloud on in your on-premise situation, or you could deploy an elastic pool of SQL databases sharing resources such as memory and CPU. You can also deploy scalable databases with dictated resources to scale up and down fluidly if there's a need or demand for your resources. So it's very elastic as well. And finally, you can run up to 80 CPU vCores and up to 4 terabytes of memory on a single SQL database vCore using the vCore based purchasing model. You can scale up to 1 terabyte of memory on a single server with hyperscale. Your core cost is micro billing, so you pay for the compute time and storage. So again, you're using up the consumption-based model to the fullest using this database solution. So this database is an excellent solution, and it's really a formidable choice as it relates to a full-scale database management system in Azure. So again, it is really probably your database of choice in Azure is the SQL database. It has advanced query processing feature. You can take advantage of high performance memory that I spoke about. You have intelligent query processing. You could choose between a fluid vCore based purchasing model, a static DTU based purchasing model, or you could use a serverless model that scales automatically on demand and your bill per second for the resource that you consume and nothing else. So it's really a dynamic solution with a lot of dynamic pricing features and a really all around great solution for you for the database in Azure. Now let's take a look at migration, and we're going to talk about the database, the SQL managed instance. It's a highly intuitive service that enables what they call frictionless shift and lift migration from on-premises into the Azure cloud. So it's really an database instance that really help you make the transition from your on-prem into the cloud with your database, and this is has to do with your SQL database. So it migrates with a lot less stress. That's a frictionless they talk about. You could use it with pod capabilities. They might want instant scope features, for example, features scope to the server and not to the database itself. Features such as your service broker, your SQL agent, your CLR, your machine learning services, etc. You could scope those features into your migration as well. So it's really, really a powerful tool that you could use for your migration. And this is pretty much covering exactly what I mentioned. It is a sophisticated deployment service that combines server enterprise database engine with the platform as a service architecture into a really versatile SQL managed instance. The end result is the ability to move on-prem SQL server instances to the Azure SQL managed instances inside the Azure cloud. And what we're looking at here is just a brief overview of the different processes that involve with the management instance, the deployment option that enables the frictionless migration. You're looking at the SQL managed instance right here. This is your Azure SQL we're working on. This is the SQL database engine itself. Everything is taking place at the platform as a service level. It talks about the easy lift and shift, the ease with which you could do it. It's very user friendly. It's full-fledged SQL instances where you get almost all the 100% compatibility with what you were doing before on premises. So in other words, you're not losing much, if anything at all. It's a fully managed platform as a service solution, and it's built on the same PaaS infrastructure with all the PaaS features you'll get. More importantly, the serverless features they're talking about here, and we talk about that as well. You get full isolation and security as well. You get native VNet implementation with your own private IP. And if you recall, when I spoke about your VNet setup and we talk about subnet, and I mentioned to you that your database will never be on a public IP. It will never be access. It should, I should say, it should never be accessible over the internet. It should always be on a private network or a private part of your subnet, and it should be isolated and segmented. So there it is with the instances and databases. Let's move on, and we're going to talk about SQL database and the three service tiers that are available. And there are the three service tiers in one shot. You get a general purpose standard, and this service is a budget tier for average workload. Then you get a critical or premium for OLTP applications that is very demanding, a more demanding workload with high latency solution for heavy workload. Then you have the Super Duty Hyperscale Service solution for extremely large OLTP with built-in auto scaling for compute and storage resources. So you get tiered solution using the Azure SQL database. So Azure SQL database is a Microsoft product, and obviously you would expect to get more features and service around their own product than you would for a third-party product. So it is preferred, in my opinion, as the database of choice in Azure, and you got a glimpse of the different features that you have using the Azure SQL database and the migration instance for it as well. Thank you. The final two databases I want to talk about are alternates to the SQL database, and that is the MySQL, both the MySQL and the Postgre SQL database. First, let's talk about the MySQL. Azure Database from MySQL. It's a third-party relational database service controlled by MySQL with Azure support. So it is really a third-party solution. I am not 100% sure if it's open source. I've never used it. Well, this is a community edition, so I think it is. Um, in Azure support both single server and flexible server model. So it do have some of the features that you get with Microsoft SQL Server. You have with MySQL, it's also popular. It is an open source relational database, so you do get relational database features with it that can handle mission critical workloads. So it's really a proven database. It's really, really powerful, and it's a good alternative to the the Azure SQL database. It also performs very well, and it is also scalable on the platform as a service architecture as well. So you do have your serverless support for it as well. So this is a good alternative solution to the Microsoft SQL. Let's look at the PostgreSQL. That's the icon for it. And this is the Azure solution that it's proffering as a solution. It's a Azure database for PostgreSQL. It's another third-party open source relational database service similar to MySQL. The Postgre database runs on the Postgre engine as a fully managed database, DBAS as a service with mission critical, with the ability to manage mission critical workloads as well. So these are two powerful alternatives. If you're already using your PostgreSQL or MySQL, you could incorporate it into the cloud and have your services up and running the same way you would on-prem using these database solutions if they are your database solution of choice. And again, they seems to be two pretty powerful and pretty popular database that can manage any workload at scale as well. Now, the enterprise grade database for the PostgreSQL also have three options. You have the single server option, you have the flexible server and preview option, and you have the hyperscale for your really large workload referred to as the CIDR. So you have that option as well with the PostgreSQL. So all in all, two real powerful database solution that you have. So together you have four databases that you could choose from or work with comfortably in Azure. Now let's take a look at the Azure Marketplace. I spoke about it briefly before, so I could get into it in a little more detail. So the Azure Marketplace is an industry-leading third-party technology store that offers up solutions to complement the Azure ecosystem. You can identify, try, buy, deploy, and interact with third-party vendors. All the add-ons in the marketplace undergo a rigorous screening process by Microsoft before they are proffered to you as a solution. So Microsoft vet these products that you could use as add-ons to complement existing services, solutions, and resources that you're able to use in Azure. The marketplace, we're gonna take a look at it in a few, but it's also provide consulting services apart from finish or pre-coded templates that you could use. When we talk about the ARM template, you could get it pre-coded one here. When we talk about we talk about application logic app and applications and API, you could get predefined solutions as well in the marketplace. But in addition to that, the marketplace also provides consulting services. So you could get consulting services there. You could get analytical services. You could get security solutions that can complement your security posture. You could get networking solution for your VNet. You could also get storage solutions for your storage, your different storage types. There's a lot of DevOps solutions as well. With high level categories you could explore for different types of solution. So it's so powerful. There are so many different solutions. I would encourage you that if you're using the marketplace and you don't see the solution you're looking for, just type it in and search for it. Chances are there will be a solution there for you. Now, the billing for the marketplace is done through Azure, so you won't have to worry about dealing with several third parties if there are several solutions that you're using. All the billing for those products in the marketplace are done through your subscription or your main account. Now, this is an example of what the marketplace would look like. It's just a general overview so you get an idea what the marketplace look like. Here are some of the consulting services that you have at your disposal. And then you have some featured apps. When you go on the marketplace landing page, you'll see the features application. You could see the most used. You could see popular solutions, and you get all that information on the marketplace. So understand the marketplace, you would be tested on it. You have to understand the purpose of the marketplace, what the core purpose is, so you could have an understanding of what the marketplace is capable of.